basically I have 3 questions that I'll try to answer. So big data, what is it? Some examples. Then some of the recent critique, as Andy mentioned, even like 2 days ago there was an article in the New York Times about a nice critique of big data approaches. And then talking about, so what does this mean for CCAFS? So in the first bit, I'll actually try to use non-CCAFS examples that I find inspiring. So what is it? What is big data? So the cost of computing and memory, etc., are dropping. On a logarithmic scale, it's if you look at the left, so it's every X numbers of years, the cost halves basically. So it's really an astronomical increase of capacity that we have worldwide to actually process data. It becomes cheaper, so people will also try to find interesting uses for that new capacity and use and misuse that capacity. And that has led to all sorts of applications of very data-intensive ways of working with data, including like putting those data in a kind of a social network. These kinds of example, maybe you know Waze, which is very useful to find your way through busy San Jose, for instance, or another busy city, where people use this app. By using this app with their GPS, they contribute to a huge global database about real-time traffic, and then other users can use this to actually adjust their route through the city. The same is being used now for weather forecasting, nowcasting, so which is actually very nice for slow runners, because you can know how much time you still have before the rain starts, for instance, with the kind of a 1-minute precision, also based on user supported data. So John, this is a suggestion for you. And then bioinformatics, of course. In bioinformatics, a lot of genomic stuff, but there are also other interesting applications. So I want to highlight this one. It was an Economist, where they actually go through database of medicines that are already approved, and then look for new uses of those already existing treatments, which is a bit similar to what we do actually with varieties in India, where we go through existing varieties and see if we can plant them in some other place. A kind of repurposing of existing medicine, so you don't have to go through all the hurdles of the approval process. So you can have really big gains by going through these databases, combining it with kind of metabolic type of data, etc., and then retrieving those ones that are promising as treatments. And then data journalism. So journalists are also now moving into this kind of data-intensive work. So here a nice example. So there's a question: is it true in Hollywood people think that if you put women in movies, you lose money basically? So there's this journalist that put together 2 databases. There's one database that is about how women are represented in movies, and another database about their financial gains. And actually, it's quite interesting. The result is that actually, if you put women in the movies, it's actually better financially. So it's an interesting kind of argument, and this is a website. It's called 538 that is dedicated exclusively to this kind of data journalism, which is quite interesting. And then crowdsourcing, I have a nice example that is actually homegrown. It's a Madrid product. So this is a website made by a small company based in Madrid that allows you to contribute as a volunteer to transcribing old weather data that was taken on British ships in the 17th, 18th century, written in a script that is very difficult to digitize automatically, but that can be done by volunteers. So they set up this whole scheme where you can get rewards. You become the captain of the ship if you transcribe an X number of pages. And apparently there are enough people to actually do this. This is already the third round. Retired people whose grandfather was the captain of that ship actually, and now find it really interesting to do this. Really successful. If you would have to pay for this, this would be impossible to do as research. And it's really valuable in terms of contributing to the database that then are fed into climate models. crowdsourcing. And there are many other applications of that kind of wisdom of crowd stuff where people use this principle that if you ask a question to lots of people, you get a better answer because you take the average of a lot of answers. There's some examples where actually broad panels of people give better predictions of world events than experts from CIA, for instance, who have kind of biased knowledge. So in summary, ICT, memory, etc., we have more and more data. Data going social. Big data is about repurposing in many different ways data that already exists, like databases on how women are represented in movies. And the trick is that since you have such large numbers, you don't need to have very precise research designs, so to say. That's at least the theory. You save money, and it's quicker, so it's real time. So that's the kind of positive side of trying to sell you big data. But maybe it's just big words, right? That's nice and so on. And now, for instance, this article was published April 6 in New York Times, where they talk more about the problems of big data. One of them is you will always find some correlation if you correlate. So how often something happens correlates with how often something other happens. If you have enough data, you'll always find something to correlate with. And this kind of was a follow-up from an article in Science about 3 weeks ago that criticized the flu trends analysis that Google developed a few years ago, where they analyzed the search data on flu. So if people type in flu in Google, there's some probability they actually have flu symptoms. So it can be a very good way to kind of early detect whether flu is occurring, and you can map it, etc. And this was kind of a critique. It now seems that it doesn't work so well anymore. And of course, this is the very basic critique. So the more variables you have, the more spurious correlations you'll get. So you'll just kind of augment the noise. And in the end, and that is the critique, it's just one big exercise in cherry picking, basically. So that is kind of the negative side of that bit. And then the other thing is, like, you have big data, but who actually participates in it? Is it a representative sample? People that search flu in Google, does that represent the whole population that might have flu? Probably not. Older people don't often have access to the internet, etc. So there are also all sorts of biases in the data. There are privacy concerns, and now especially with the kind of the debate, especially in the US, about uses of these data by the secret services, of course. So this is how I kind of look at it. I think, like all new technologies, there's a hype cycle. So you get a technology trigger. It starts somewhere. Then you kind of quickly climb to the peak of inflated expectations. And then you kind of fall off the peak and you go to the trough of disillusionment. But then kind of people will find some uses for it by climbing the slope of enlightenment. And then they'll get to the plateau of productivity. And I want to do a quick test of a kind of crowdsourcing test. So what do you think, where is big data right now? So can you just raise your hand if you think we're now here, the technology trigger part of the cycle. Just raise your hand. 1, 2, 3, 4, okay. Who thinks we're at the peak of inflated expectations? Okay, 1, 2, 3, 4, 15, 16 or so. Who thinks we're at the trough of disillusionment already? 1, 2, 3. And then who thinks we're already climbing the slope of enlightenment? Oh, wow, very, very optimistic. Who thinks we're at the plateau of productivity? Nobody. Okay. The majority says we're at the peak of inflated expectations. So I actually have some data on this, of course. So big data is right there. So it works, right? Evidence is there. Big data is at the peak of inflated expectations if you kind of analyze the data. And you can see all the other kind of hype technologies. We can also see that some of these technologies are actually already climbing the plateau. Like enterprise 3D printing is now actually becoming an established technology, right? So it actually, it doesn't mean that we won't be here at some moment. And maybe CCAFS can kind of jump like, directly to the plateau of productivity, right? So how are we going to do that? So in summary, there are all sorts of caveats that also apply to all sorts of statistical research in general. I don't think that's a very new critique to say that you can have spurious correlations. Big data is on the peak of inflated expectations, but there's a plateau of productivity ahead, right? So what about CCAFS? What can we do in CCAFS? And I don't think this is completely kind of new to CCAFS. I think in the last 3 years we have been doing things that are related to big data. For instance, the analysis of historical trial data through ECT trials is trying to put together in a single database in a very consistent way all the trial data that the CG has been generating over the last decades. That will be a very valuable resource to do all sorts of research, and I'm just waiting for the data journalists to download these data and do correlations with women in movies or so. And then the other thing is what I think is very valuable, that we've also been able to actually identify some big data illusions. Like people think that there are lots of data, but many times in the context where we work, it's actually a very data sparse environment. For instance, this is the work done, for instance, by Julian, very highly cited article, I guess, about how many stations you actually have data from in the public domain, and that has been dramatically going down in East Africa and South Asia over the last decades. That is a really worrying trend. Like climate change concern goes like this, but actual data availability goes like this. That is a real concern, right? And that. We can talk a lot about big data, but this is a real limitation to big data approaches, of course. So what do we do about that? There are always solutions. So one of the things that we can think about is the use of sensors, automatic weather stations. So I'll talk a little bit about the bioversity work that we've been doing. We've been trying also to look at how can we use sensors to actually get plot level meteorological data that we can then link with trial results. So we've been using these very small sensors. They're cheap, robust, and they can store data for quite some time in the field, and then we can retrieve them. They're now being used quite a bit in ecology. This is the manual how to do it. CGIAR work also on using big data approaches and generating data with farmers, and then coming up with, through an analysis of the data, with the kind of site-specific recommendations based on data that farmers themselves contribute. And Danielle will talk about this in a session later today, about how that exactly works. And then citizen science approaches, crowdsourcing type approaches to do this. So one of the good things is, and that it does have a real impact in Africa, Latin America, and Asia, is that the single piece of ICT that most farmers now have in their hands is a mobile telephone. And so how can you use that with this kind of big data philosophy or citizen science philosophy? So what we've been trying to do is to think through the issues and come up with an approach to do this for variety testing. We've come up with a very simple approach where farmers get each 3 varieties. They plant them out in the field, as you can see here in India, 3 varieties. And then what they do, they rank these varieties. So they will say variety 2 is the best, then it's number 1, and then it's number 3. And we get those results for many varieties and from many farmers. So we have big N on both sides. We combine that, and then we can use some very nifty statistics that are quite innovative the Bradley-Terry model with recursive partitioning is really cool. And it kind of shows you how different groups have different preference profiles. And I'll just, I won't kind of bore you with the data that we get from India and from Honduras and from Ethiopia. I'll just go to the original paper where they introduced this. So they used a very nice data set. They used the rankings from Germany's Next Top Model 2007 data, and they asked people to rank the top models. It was kind of really interesting because you have like an elusive concept of beauty which you can actually start to quantify with this approach. And what comes out of it is that, for instance, age is a really important factor in influencing how people perceive beauty. So you can see how different groups are in the data. So people over 52 have very different thoughts about beauty, and they think, for instance, that this woman is far more beautiful than the other groups, for instance. So it's quite interesting. So you could do the same thing for varieties, right? So and for sorry, this is the original paper. It's just the lead author was a woman, so just to balance with the gender, the Hollywood gender story. So you can also do this for varieties, and you can get things like gender and age and farm size, etc., as variables in there. And you can get different preference profiles for varieties. And they can also do it for other things like management practices, etc. Okay, next time maybe the varieties, right? And then in the end, that should all add up to a kind of a system like Waze, where you give data and then data comes back to you, and in a kind of a seamless way. So this is kind of the vision of this project, and we're now doing this with 5,000 farmers in India. We're starting to do it with 2,000 farmers in Ethiopia and East Africa. We have a project in the pipeline to do it with 5,000 farmers in Central America as well. So it's really a scalable, a quickly scalable type of technology because it's so simple to implement relative to other approaches. And then I was sitting next to Wiebke earlier, and we were talking about, so can we use crowdsourcing also for something else in CCAFS where we, in the future, will need to spend a lot of time. So we're kind of brainstorming about, can we use this crowdsourcing approach also for monitoring and evaluation? And of course we can. So one of the things that I came across in going to these ICT4D meetings was somebody from Grameen who talked about the progress out of poverty index. And I thought it was really cool. So what they do, they get these huge household databases that we also do, like with Impact Light and so on. And what they do is they try to identify 10 variables that correlate highly with poverty and that are easy to measure and that you can then use to classify households in different kind of poverty classes in a statistical way. You can actually say this household has this probability of falling below the poverty line. If you do that for many households, you can actually have a very narrow estimate of the level of poverty in a large area and monitor that over time in a very light way. This is now being used in many, many countries by many, many NGOs. And we wondered if this would also be possible for CCAFS. And actually, it's in one of the concept notes. And Mark van Wijk is going to do it for us, right? So this is, and actually, if you look at the website that Grameen has, for this, they already proposed like these methods by using SMS or using cell phones. So in conclusion, data is the new oil. That's that's what I propose as a slogan for a new slogan for CCAFS. But some work is required to get it out of the ground because the data are not there yet. We need to create them, most of those data, because we do work in data sparse environment in most cases. So just to make a little announcement for the session later today, we'll have 2 short presentations from Dieudonné, from SIP, and from Daniel about big data, and then we'll have like a debate about what are the opportunities for CCAFS to use these types of approaches in doing research. So thank you very much.